This is the introduction for Module 7 from Making Spatial Decisions Using GIS and Remote Sensing. And this module will take you through the process of classification accuracy. Now that you have performed unsupervised and supervised classification, you will explore the idea of assessing the accuracy. So we start with the concept of ground truthing. It is the process of sending technicians to gather data in the field, and it either complements or disputes airborne remote sensing data that is collected by aerial photography, satellite side scan radar, or infrared images. Here's an example of a technician with a spectrometer, and this technician is collecting spectral signatures of this grassy field with a handheld spectrometer. So ground truthing can also be called ground referencing, and this is the process. You will compare field data or higher resolution imagery to classified map data. For this module, we won't be sending you out in the field, but we will be using higher resolution imagery available from your ArcGIS software. The accuracy depends on taking ground reference points at a scale that matches imagery in your classification. So you want to make sure that you're working in the same scales, especially when you're testing the accuracy of your data. And you want to make sure you have a sufficient number of random points. In an extended project, you would want to have 25 to 30 points per class. That's a reasonable estimate. For this lab, you only need to do 25. For time's sake, we're just learning how to use the tools. So you're going to look at errors. There's two main types, omission and commission. So omission means that you're leaving something out. Categories in the analysis have been omitted that actually exist on the ground. And commission means that you're identifying categories in the remotely sensed data that do not actually exist on the ground. So here is an example of a matrix, and this is very similar to the results that you should get for this lab. You're going to create random points. These are 25 points generated from online imagery. And the imagery that you'll get will be from the ArcGIS software. You can see on the left here that by using the Add Data button, you will then add the data and find the base map imagery to use. On the right is an example of 25 generated points, and yours will differ. You will then create 30-meter buffers around your points. And here's a tip with the software. Zoom in to view the buffers, and then you will be able to see these. This one here is shown with a circle of light blue. If you're zoomed too far out in your data set, the buffers won't show up because they're only 30 meters in diameter. When you classify your random points, a tip for making this easier for you is to right-click on a point number in the attribute table and then select the feature Zoom To. That will zoom you in your map layout to the point, and this example here is showing point number 4, and it is highlighted in blue. That will then help you to look and see what land cover classification that point is actually on. And so in this example, this blue point is in urban area. So for deliverable 1, I wanted to make a note about this map layout is missing the following information, a title and projection information. So really, this is a screenshot. So I just wanted to be very clear, because there have been some points deducted in labs, that a screenshot is not the same as a professional map layout. When you share your information with your coworkers, your clients, and with your professor in this example, you want to take the time to do a professional map layout. So this is actually a professional map layout. It has the elements that are required for, and these are map elements: title, author, data source, projection, scale bar, and north arrow. Now, a professional map layout doesn't need to be fancy, and in this case, you want to think about who is the audience you're communicating to. Well, we're practicing as students, so your audience is your professor. This assignment, deliverable 1, asks for a table, so there is a screenshot table. This was inserted with ArcGIS software as a picture. I just took a screenshot of my table, I saved it as a picture, and I brought it in to my map layout. And then you can see here I have my data source, which is the textbook, and the projection is listed there. Just a note on the scale bar as well. Scale bars are created pretty easily with ArcMap software. Make sure that your scale bar has rounded units. You wouldn't want to use, for instance, something like 40.3 miles. That's not going to make as much sense to the reader as this example of 40 miles. Deliverable 2 and 3 will be an error matrix, and this is, again, the example of an error matrix that you saw earlier, and your written analysis should be sentences and a summary of what you have found. Here's another tip. When you are searching for tools, use the search for tools function, and you can find this by going to the menu option called geoprocessing. Go down until you find search for tools. And on this one, in the right of your screenshot here, I've entered in extract values to points. You can see that my search has returned 3 items. Then you can click on the tool that you want. This is a much more efficient way to search for tools than looking for all of the options in your toolbox. This concludes the introduction for Module 7. I hope you enjoy this lab.